So the first thing we need to do any classification is to get our hands on a data set, folks. And these are all of our lessons in the methodologies will follow the data science pipeline, short of the presentation part. We're not going to give you tips on presentations. You will do a presentation at the end of these modules, right? But our goals here are to get our hands on data from a variety of sources: CSV, SQL, Excel. Check this out. You've seen some of these methods before. You've worked with read CSV, you've worked with read SQL. There's also a read Excel function, which you read an Excel file, XLS, XLSX. You can even read from the clipboard, which is really wild. So if you copy a table of data from a web page, you can paste it into Pandas as a data frame with pd.read clipboard. It's the cat's pajamas. It's really, really cool. So we've done some of this stuff before. Reading Excel is very similar to CSV. And we've already talked about how to talk to a database. You have already installed PyMySQL, and we have already created an env file. So your gitignore and your env, you're going to want to copy over to the new repository for your classifications exercises, and then we'll be using them. Yeah, great.
How we getting your file or global?
Mm-hmm. Yes, I want as many layers of security as I can get for your passwords.
Sure.
Yeah, and let's say you have a globally ignored env file, and we're working on a project. If we're committing to the same repo, but you're relying on your global gitignore, and I don't have a project or a global gitignore, I could commit my credentials. So I would encourage all of us at all stages of the game, make a global and a global for your computer gitignore and a repo specific gitignore, because you never know what, we can't assume anything about our collaborators, right? All right. So check this out. We can even use Pandas to open up Google Sheets. So let's say you've got some Google Sheet link. Now this blah, blah, blah is an example. This is kind of an abstract example. But with a little bit of string manipulation of that URL, you can change what you'll need to do is change the /edit followed by the unique identifier to /export, set a format to CSV, and then bam, you've got that content. I'll show you what I mean. The sheet URL is this string right here. And if we were to open that up in the browser, we'd see that it is some Google Sheet with some data. Some, I guess, this is Titanic data. Okay, and by changing the URL ever so slightly, instead of having /edit, we perform a string replace. The code is right here. It's really cool. We'll do a string replace and swap out edit for export and add on the format to CSV. And bada bing, bada boom, you can send read CSV a Google Sheet. You can also send read CSV a web address of a CSV file or a web address of an Excel file. Well, yeah, the URL is a string. And by doing some string replacement, swapping out the edit for the /export format CSV, then you can use that URL to read that CSV directly. And don't take my word for it. Fire up a notebook and run this code from the curriculum in there. These like 5 lines of code, and you will get this data frame. It's really cool. Other sources of data, I talked about read CSV can read a CSV that's hosted on the internet as long as it's publicly accessible, right? There's no authentication. So this CSV that we're linking here on this Amazon S3 bucket, this is publicly available and it is IRS data. Exciting. So if you've got a CSV that you can view in a browser, copy that CSV's address and you can read it in Pandas. Really cool. Awesome. We also talked about SQL, and you did use SQL. Here's the most important thing about talking to SQL through Pandas. We're going to talk through the get connection function. And that get connection function takes in, it's going to rely on your provided user, host, and password from the env file. Let's see how this is taking in a string that contains a database name. And how do we know our database names? There are, when you say show databases on your client, you'll see all of the available databases. Okay. And so this says, hey, establish a connection to the Titanic database on the CodeUp Cloud SQL server and select start from passengers or whatever your SQL is. So your SQL comes as your first argument. You could send in a string literal, or you could send in a variable containing a string. Generally, I encourage y'all to triple quote your SQL because you might have quotation marks inside of your SQL. Cool. Something that you may want to consider, it's probably in the exercises, but you may want to consider this both on the job and as a best practice. But you need to be mindful of this is this idea of caching your data. So much like if you were to build a cache of Band-Aids and cans of beans, you're saving things for later so they're right at hand and not at the store, right? We can cache our data locally. So instead of having to make a round trip effort, send a SQL query across the internet, it's got to run on that SQL server, and then it comes back. If the contents aren't changing, like the employees database, contents aren't changing. They stopped updating that in the 90s or the 2004 or something like that, right? If the contents don't change, this is a good option. If your contents change daily, this is not a good option. So to cache your data, what we would do is get ourselves a happy little data frame from whatever SQL we write or whatever scraping. We will definitely want to cache the results of scraping data as well. So you get a data frame from a query or from some source, and then check this out. You can write your own CSV files to disk you start with the name of the data frame, the variable that holds your data frame. It could be whatever the name is, right? Your data frame could be telco, could be Titanic. It doesn't have to be DF because they're variables, right? To CSV, and you provide a string name with the .csv, and this little function is going to write a CSV of the entire contents of that data frame to disk. Now, why is this useful? What's that, Jen?
I was going to say, print it to CSV.
You could print it to CSV, Andrew?
You don't have to query the SQL database every time you need it.
You don't have to query the SQL database. Yeah. And the nice part is if you've got a local version of the data, we could work on this on an airplane, right? Or somewhere where you don't have Wi-Fi. The downside is, and we need to be mindful when we cache things, if you cache a copy and you're working on the cached copy and the original source changes, you have to have your head on straight. You can't just always work on the copy thinking that it's the original. But the big value here is what if your SQL query took 5 minutes to run?
Like this also be useful
Yeah.
if you want to like share to stakeholders or somebody that may not like have.
Yeah, absolutely. The question for those of you remote, the question was, could caching be useful for sharing the data with stakeholders who are not necessarily technical stakeholders? And my answer is an emphatic yes. Because if you've got a CSV, you can open it up in Excel, give them an Excel copy, right? If they think they can noodle around in the data and feel better about themselves for having the raw data, right? But the big cost of a cache is if you need a fresh copy, you've got to nuke your cache, right? Here's an example. Go ahead. I have a question from Lincoln. Go ahead, Lincoln. You've got the floor.
Hey, Ryan. So I wanted to ask if you do the copy of clipboard, do you have to give it a variable name in order for it to save? Like, I don't know, like how do you have to convert it to data frame in order for it to save? Or if you just copy the clipboard and then you copy something else on top of it, will it go away? You know what I mean?
I I heard some of what you were saying. I don't know, the audio quality was much lower than normal. Was it about the file name or the variable holding the data frame?
Wait, I don't know if I should speak louder or just normal but slower. Can you still hear me?
I'm hearing you a little bit better. You sound kind of like you're in a tin can.
I don't know what's wrong because my mic is like right here.
That's a little better. Yeah.
Okay, maybe I just speak in the mic. Okay, well, I was just asking. About the copy to clipboard. Do you have to assign it to a data frame in order for it to stick? Because if you copy something else on top of it.
Oh, the clipboard.
Yes. Sorry for taking everybody back.
Yeah. So the clipboard is going to read from your clipboard and write and give you back a data frame. pd.read clipboard returns a data frame. So it's up to you to store that to a variable. If you don't store it to a variable, you don't get to work on it later.
Okay, got it.
Yeah. Read clipboard will read anything you put on your clipboard. So if you copy an image, it's gonna be weird. You might even have an error. But if you copy like a table of data, it'll play nice with you, like a table from a web page or an email or something like that.
Kyle's got a question too in the chat.
Yeah.
Oh, here we go. Kyle, I did this with one of the exercises before. The resulting file was too big to push to GitHub. That's totally going to happen. I think 50 or 100 megs or higher. Should we put that in the git ignore? Yes. And also, once I had already tried to push, I had to do a soft reset local branch. Yeah, there's a couple of ways of pulling something out of your commit history. But yeah, if you've got a 100 meg file, that shouldn't go up to GitHub. It's not going to fit. But you will still have that copy locally on your computer. So yeah, it's add that large file to your git ignore. Yeah, for sure. Now, if your file is like 5 megs, forget it, doesn't matter. I'm not going to store that somewhere else. I'm just going to throw it in GitHub. Cool. So definitely project stuff where you have like lots and lots of data coming back. If it's, I think, less than 50, you can 50 or 100, I forget, you can save it. So let's take a look at the implementation, the code implementation for caching something. So check this out. Something new y'all probably haven't seen before is importing a module from Python standard library called OS. This is a Python library to talk to your operating system. So you can go from Python land to your operating system. It's really cool. So when we take a look at the guts of this function here, the function is called get Titanic data, and it will do exactly that. The first thing that we're going to do is set a file name as a variable. Because we reference the file name variable a couple of places, having multiple references point to the same exact file name is going to be more easy than having a string literal everywhere. Let's take a look at this first bit of code. If os.path is file name, well, how to read that is if the path to this string is a file name, then we return a data frame where we read from that local CSV file, pd.read CSV, and it's reading straight from titanic.csv. That's if the file exists. Otherwise, if the file doesn't exist, go ye forth across the internet to the SQL database specified by your get connection function and beseech the SQL server to select star from passengers. And verily unto thee you will be delivered a data frame from pd.read SQL. And you'll also notice once you have that data frame, the else is only going to run if you didn't have that file. So the second thing, we write that file name to disk. Then we return the data frame to memory. So this is an example of code that would be in an acquire.py script. We don't necessarily need this at the top of your notebook. We really want to reserve your notebooks for data exploration and modeling and documentation. At least like final notebooks. You might cram this at the top of a scratch notebook. Cool. The biggest thing to remember is if you need a fresh copy, delete your local copy. Mindy, did you raise your hand?
Sorry, just the acquire, so that's just basically making it easier. Right? That is-
Oh, if we put this into a Python script?
Right.
Yeah, if we put this into a Python script, then if you and I are working on the same repo, we import that acquire file and call this function and you'll get the data. You don't have to write all that code. So it's really nice for reproducibility. If you're trying to reproduce somebody else's work. And it's nice if you're doing group work, you don't have to write the acquisition code over again. It's in one place. Because like notebooks are really cool, but notebooks aren't great for sharing quite as much as like a Python script is built much better for sharing and executing. Did that speak to your question or did you have a follow-up?
No, I think so. I think so. Yeah.
I'll give you an example. Would you like to see some code of how to do this?
I think so.
Okay. I'm going to make sure that I don't do the exercise for you. Telco, sheets, customer details. Oh, there's some Titanic in here. Okay, whatever. Find some data. Let's just find some random CSV somewhere. Hey, mall customers. Here we go. I've got a data set with some mall customers. So from here, this URL is not the CSV. So I need to click raw to get the actual CSV in the file extension. And I'm going to copy that. And I'm going to go over here to my Jemison data science folder. And I've actually got to make a new repo, don't I? You too will make a new repo for this. So whatever the repo name is, classification exercises probably. Yeah. We'll do github.com/new. Make a happy new little repo. I'm going to call it Jemison classification exercises. And this doesn't go to my own account. This goes to Code Up Classroom. It's public, so y'all have access to it. The repo already exists. Okay, cool. This tells me that I've got a colleague who's ahead of me or doing some work in this repo already. I don't need to create it because it says it's already exists. So I should go check. Jemison classification exercises 35 minutes ago. Cool. So my colleague already set this up. What I've got to do is copy this. So Adam already did the work to set this up. What I'm going to do is clone this, and then I'm going to rename it, not Jemison classification exercises, but just classification. Classification exercises. And we'll change directories in that. So there's nothing here. Let's get something here. I'm going to open up VS Code and make a file called acquire.py. So what I'm going to demo for y'all pay no attention to the other programming language behind the scenes over there. What I'm going to do here is import pandas. And then I'm going to make a function called get mall data. And what this is going to do is set file name equal to, see, what is this file's name? That's not it. It's over here. There we go. So file name is mall customers.csv. And I'm going to also import the operating system, the OS library. And I'm going to say if os.path.is file. So if I have a file that has that exact file name, then what we'll do is return PD read SQL or read, this is CSV. I'll do that. I can say otherwise, that URL will return pd.read CSV. That URL, and I also want to say store that as a variable, then write that to CSV, and then I'll return the data frame. So what you're looking at here is identical to the caching code that's in the curriculum, except for two things. The data set is different. It's mall customers instead of Titanic, because I'm not going to do the exercise for you. And the other thing that's different about this caching version versus what's in the curriculum as an example, and is I'm reading the CSV from the raw source rather than the database. I don't know if the database has this mall customer, so let's take a peek. Maybe if it is, I'll reduce the difference there. Let's say show databases. Do I have mall customers in here? Hey, I do, cool. So let's do use mall customers. And there's a customers table, so conceivably we could do select star from customers. Okay, that works. Let's change this up a little bit. On my terminal, I do not have a getignore or an env, so I'm going to slow down a little bit. Take stock of where we are. I've got this perfectly built caching mechanism, but I'm asking you to suspend the disbelief that there's SQL here. So I found that this data set does exist on the database, so I'm going to pull it, make that SQL happen. In order to do that, I need to copy from another folder my getignore. Period means this here folder. And then I'm also going to copy from the DS libraries. I'll copy env.py. Put it right here, right in this folder. LS will show us, LSLA will show us we have the getignore, we have the env. Which means over in my Python script here, I can do from env port get db URL. And we can change this up and move from the CSV to the SQL. And so we'll say get db URL to mall customers is the name of the database. I'll double check that. Mall underscore customers is the name of the database. My query is pretty simple. It's select star from customers. And then instead of reading the CSV, I can read the SQL and feed it the query, the URL. Okay, so I'll commit this so you have this as reference here, okay? The only thing that I've done differently than the curriculum example here is since I'm importing my my get it DB URL from the env, and I'm talking to a different database.
Does the return have to say file name? The one under it.
This one? Oh, yeah, that should totally be file name. Absolutely. Thank you for keeping an eye out, because that's the variable here. We would get a name error if I tried to run this code. Okay, so I'm going to take that as Gesundheit. And now that I want to use this acquire get mall data function, I can make a happy little notebook. And I'm going to say in my happy little notebook here, I'm going to make a brand new file. A brand new file, we will call this acquire lesson demo. And in my imports, I do have to import pandas in here. I'll import any other imports I need to import. One that's a big deal is I will say from acquire import get mall data, because that's the name of the function. Let me double check. Get underscore mall underscore data, no inputs. Okay, so I can do that. Now I can say, let's make a data frame out of get mall data. And the first thing this line of code is going to do underneath the hood, it's going to check this folder and see if there's a CSV file in here called mall customers. Well, there isn't. So it's going to reach across the internet and make a SQL query. There you go. After writing this query, after reading this query in from SQL, check this out. We now have mallcustomers.csv. So this is the cache. So now, if the internet went out, I can keep working on this data set. Yeah, absolutely. And I'm importing pandas as well. The imported acquire file uses pandas. We have to declare here too, if we want to use pandas in this file. I thought I saw a question.
Is there anything separate on the CSV file or is it like what type of file?
CSV is basically a spreadsheet. It's a spreadsheet without all the formatting and bells and whistles and metadata. That's like if we were to open up the spreadsheet with a text editor, just a simple text editor, what makes a CSV is comma separation between each value. And so we have the index, a comma, I should fix that index crap, and then all of our columns separated by commas. Each record is separated by a new line character.
I was just thinking that I was looking at the Pandas documentation, they have like, you know, XML.
Oh, yeah.
Is there anything, I mean, I don't sometimes use data.
Oh, yeah. It's probably one of the most popular ways of data transfer on the planet. So the
Really just like which file format is it?
yeah. So for those of you joining on the remote call, Stephen had a really great question. He said, is CSV, is that a choice? Where is that coming from? I was looking at the docs and seeing some other functions. Yeah, there's read XML, there's read JSON or write JSON. Byte for byte, a CSV has more data, more signal than duplication than a JSON file does. JSON file is duplicating all of the keys because it's a list of dictionaries. So pound for pound, a CSV is leaner and meaner. Yeah, and if you have to deal with XML files, then I feel for you. But XML is really cool because you have a lot of rich metadata. There's no metadata at all here. It's just the data, right?
I need to like that.
Oh, beautiful. Yeah, absolutely. Yeah, actually, I hadn't heard of the Tula Tech.
That's perfect.
Tula Tech to quit. Cool. So now this data is mine. If I run this function again, now I can't simulate turning off my Wi-Fi because I'll lose the call, right? But what I can do is say, what if I just nuke my ENV? It's gone. I no longer have an ENV file. I have no ability to talk to a database right now. But when I run this function again, because the guts of the function check to see if there is a mall customer CSV, that's just fine. Over. So this is one of the benefits of a cache copy. The other main benefit is if your query takes a long time. Yeah, I see a question up for Jules. Go ahead, Jules.
Okay, so the difference between your two functions, right? Well, not even your two functions, but the get ignore, not the get, I'm sorry. When you went to the get and you went to the raw, the only reason that you did that to get that particular URL is because you had it on get. If we just generally had a URL where something was, okay, I just wanted to confirm that.
Yes, yeah. I'm glad you're asking about that, Jules, because this is really important for files on Git. Even if you're like looking at a notebook on Git or GitHub, it's not the same thing as looking at the raw data. So see how we get this little preview and all of this other junk on here to edit and make changes? The URL does not show CSV. So we click raw to see the actual raw data. And that's how I'm getting that right there. This also shows up with notebooks too, right? If you want to if you wanted to grab a notebook. So if we were to open up grouping and apply this notebook here, the file name in the URL says Jupyter Notebook, but like, where's the download button? And how do I save this as a notebook? You'd actually have to click raw to get the raw source code for that notebook, and then you can save it as a IPYNB, or just copy and paste this into a file, and you have a notebook. Yeah, did that help?
Yes, thank you.
Cool. So this is what I've demonstrated for you here with this acquisition script that's separate from the notebook. This is going to be more and more, this is your life. This will be your life more and more in class, where if you have to do your acquisition code in a notebook first, you're just more comfortable in that environment, cool, but take that work and add it over to Python script. And then we'll import the script. So we're hiding details because we want most of our notebooks to be about text and communication, visuals, hypothesis tests, and modeling. So exploration, basically. And there you have it, folks. Data acquisition with Pandas, even more Pandas than we have done before. We're going to do this throughout a lot of these modules, to sprinkle in a little more Pandas, a little more methodology. It's not just like we jump straight into the modeling. So we're going to keep going through this data science pipeline through classification, through regression, through clustering, through time series. Then you'll do it in an individual project where you go through the whole data science pipeline on a data set of your choice. And then we move into NLP and anomaly detection, same deal. Plan, acquire, prepare, explore, model, deliver.
I was just looking at the
Yeah.
exercises and for when we create our ignore.
Yeah.
So there's a couple things that I was worried about the DS store.
Oh, yeah. Let's visit about these, because you might not have seen these file names before, and it's like, what the heck's going on? So env.py, we know that's your env file. DS store is this funny little file that's generated by a Mac computer when you open a folder up in Finder. If you never open a folder up in Finder, that file never exists. This is storing meta information. You know when you set your view to like view by list or view by icons, that's where it's storing that information temporarily. But if we're doing group work, we don't want each other's DS stores. And the DS store is meta information about your own file system that's not the source code. So I would ignore that. The IPYNB checkpoints, that would also be problematic for group work, because your autosave checkpoints are different than mine. And same thing with PyCache. Yeah, these are generated by notebooks or by running Python code. Yeah.
As long as just these 5 things are.
Yeah. And then the star CSV here, this is saying any CSV. That's what the star means. It's a wildcard on the terminal. And this is listed here to make sure that we don't accidentally commit, 100 meg CSV. And then, oh, Ryan, I can't push. Oh, Adam, I can't push. Because the file's too large. We want to save y'all from that. All right. Yeah, great questions. Great questions, y'all. I'm going to add, commit, and push my work. I'll send y'all the link. And taking a look at these exercises, I think it's very reasonable that these exercises could take us the rest of the day. We'll play how about we play the review by ear? I don't want to take away your time. This is a big wall of exercises, so I don't need to do the review today necessarily. But if all of y'all are just rocking and rolling, we'll do the review. All right, we got plenty of breakout rooms. If you'd like,